In this video, I'm going to show you how to use the graphing calculator to see your image of your function and also, check the points to see if they're actually the correct points. We'll begin by going to our graphing calculator. I'm going to hit the y equals button, and here's where I'm going to enter the equation. I would like to enter the image y equals square root of x minus 4 plus 6. I need to do this particular equation because if you look over here on the calculator, I'm only allowed to do y equals, and in this case, I can't do the y minus 6. So I'm going to type in the square root. Now, the square root key is found above the x to the second, so I will hit the second and then hit the x squared to get the square root key. Now, what you're seeing here is me being in math print mode, which is a feature that's available on all TI-84 models. And if you don't have the math print mode, you can get your calculator upgraded. What you will not see is math print on any TI-83, and nor can it be upgraded. So after I'm done with this, I will switch it to classic mode so you can see what that will look like. But I can actually now hit the X key here. You may also hit the alpha store key for the X, but this key is dedicated for graphing. The xt theta n represents each of the independent variables based on the graphing mode that you're in. And the graphing mode can be selected by hitting mode, and over here you got function, which is where it uses the X, parametric, which uses the T, polar, which uses the theta, and if you do sequential graphing, you would use N. Since advanced algebra is really only going to be focusing on function graphing, let's go back to y equals, move over to the inside. I've hit the X right there, and I can just go ahead and hit minus 4. When I need to get outside of the radical, basically I'm done with the radicand, I just use the arrow key to move outside of it, and then I go ahead and type in plus 6. Before I go actually graph it, let's show you what this is going to look like if I was to have done this in classic mode. So I'm going to go over to mode. I'm going to find, now if you don't have a second screen, then you don't have math print. Again, if TI-83 cannot be upgraded, but if you have a TI-84 that doesn't have this feature, you can get your calculator upgraded. So I'm going to go to the second screen. I can either hit the up arrow to get to the second screen and work all my way up, or I could have gone down. I'm going to switch over to classic. I'm going to hit enter. If I need to be done with this screen, I'm just going to hit second, and I'm going to hit mode, which is quit. And then I can go back to my y equals, and you'll see that my radicand is going to be enclosed by parentheses, and the plus 6 will be outside. Now I'm going to go look at my Windows settings. My Windows settings may not be the same as your Windows settings, and I'm not sure what I used the last time I did this, so I'm going to look at Window, and I see I have it going from -10 to 10. That's a really nice Windows setting, and I actually can get those settings if I do zoom number 6 Z standard. The issue with that is that it does distort the graph because it ends up looking a little wider than it should be, because your -10 to 10 is supposed to be the same distance as height-wise, and this calculator has a little wider width, than its height. So I would like to have is a 1-to-1 ratio. So I'm going to pick number 4 Z decimal, and I'm going to hit enter. And what this is going to do on a TI-84 calculator is, or a TI-83 that's black and white, is it's going to give me Windows settings from -4.7 to 4.7. And that would mean from -4.7 here to +4.7 here. My Y min will be -3.1, so that'll go no lower than this, and this is going to be 3.1. Now, if I had a TI-84 color calculator, which I've now pulled up with the equation in there, and I would hit zoom, and I would go ahead and hit Z decimal, I'm still not seeing anything, but the screen, you'll notice, it seems to be going a little farther to the left and to the right, and the height's a little higher. And if I go to my Windows settings, you'll see that I have a different set of settings. The TI-84 is of a little higher definition. However, the key is over here is my first point, and that point occurs at 4,6, and my height doesn't go any higher than 4.1 even on the TI-84. So the graph is like up here. It's supposed to be graphed, but I can't see it. So one of the little tricks you could do is you could manually change your Windows settings, or you could go to zoom and you could hit Z standard and go back to the -10 to 10, which in this case is that setting right there, and you can see the graph. The nice thing is Z standard on the T84 plus CE is similar to the T83 and T84s. But the other skill I would like to show you right now, and I'm going to be done with the 84 CE, so I'm going to close that out, is I would like to show you how to do zoom out. So what I'm going to do is hit number 3 after hitting the zoom button. And if you look carefully, there's a blinking cursor right now at the coordinate 0, 0. If I hit enter, it's going to zoom out based on certain factors. And since these are the default factors, it's going to zoom out 4 times in different directions. So when I hit enter, 0, 0 will still be the center, but it will zoom out. Now, if I move the cursor by, let's say, doing this, I can recenter where my center is and zoom out that way. But I'm going to stick with 0, 0 as my center, and I'm going to hit enter. And what you're going to see now is, well, look at that. There's my point, and the window settings are from negative 18.18 to 18.18, which is definitely between covering 4, and from negative 12.4 to 12.4, which easily is covering the height of 6. Those settings can be found under zoom, and go to memory, and go to set factors, which is number 4, and their defaults are 4 and 4. If you don't want to zoom out that much at a time, you might want to set those to 2 each, but I'm just going to keep the default settings. So now that I have my graph, what I can do is I can go look at the coordinates of those points. Just to kind of help us along, I do want to show you the pre-image, the parent function. So down here I'm going to type in the square root of x. I'm going to go ahead and hit graph. There's the image, there's the pre-image. And I'm going to go back one more time so I can show you this all again. I'm going to go back to zoom, I'm going to hit Z decimal, and we're only going to see the pre-image, the parent function. The reason why I chose to do Z decimal, number 4, is so that if I were to trace, okay, let's go hit trace, and I use the arrow keys, it will count by 0.1. And if you look carefully, eventually you should see, oh, the reason you're not seeing it is Y1 is off the screen. So you can actually bounce between the graphs by hitting up and down arrows. So Y1 and then there's Y2. So I'm actually on the graph now. And if you look, it's counting by 0.1s on the X's. On the other hand, if I would count and go zoom and then choose number 6, Z standard, yes, I'll see both graphs, but the reason I don't choose this too often is when I go ahead and trace, I'm not going to land with some nice x coordinates. I'm not going to have, it's going to be equal distance, but it's not going to be like 0.1 or 0.2. It's going to be whatever it can to go from negative 10 to 10. And so even if I go to down arrow, you're going to get some very interesting values. Now, one more time, if I go back to Z decimal, I may only see the one graph, but if I now go zoom and then hit out, and I'll hit enter at 0, 0, when negative 4.7 got multiplied by 4, because that was my set factor, 4.7 got multiplied by 4, my y's were multiplied by 4, so negative 3.1 and 3.1, giving me these window settings. When I trace, I'm going to count by 0.4s. So 0.4, 0.8, 1.2, 1.6. Since I have no value here, it's saying it's not defined for the Y1 graph. It is defined for the Y2 graph, but not the Y1. But when I finally get to a value that is defined right here, 4.6, it will show me 4.6. It will also tell me if I go down that if I was to take in the square root of 4, I would have just gotten 2. So you can see that I have matched up my first point at 4.6. Well, what I want to do is be able to show that all these points actually work. So if I go to 4.6, I should be able to go to 5.7. Here's the issue. Since I'm counting by 0.4s, I'm going to skip right over 5. I can keep going all the way to 8, because I'll land on it, and I'll see that I get 8.8. But I want to be able to check what happens at 5. For this, I want to use one of my calc features. I want to go second, I want to go trace, or in this case calc, and I want to choose number 1, which is value. And what I can do is now I can type in any x value that happens to fall between well, in this case, negative 18 to positive 18. So I can type in 4, hit enter. Now, since y1 is graphed there, I can see the 6. If I did want to see what happened at 4, I can still use the down arrow and click on y2. If I want to now calculate for 5, I can just go back to second calc, choose number 1 value, hit 5 for my x, and jump there. With value, you do not need to keep typing second calc. As long as you're in the mode, I could just go ahead and hit 8 and get 8. I can type in 13 to verify there's my 9. But what will happen is that if you do choose a number that is outside the domain, remember, my domain happens to be between negative 18 and 18, and I decide to do a value of 20, it will give me an error because it's outside the domain. Either increase your window settings or just stick with numbers that fall between there. I moved on to example number 4, and I would like to type in y equals the absolute value of x. Let's get back to y1. Go to math, go over to number, and choose ABS, which stands for absolute values. The nice thing is this was math print, you would actually see little absolute values. I'm going to enter the equation x minus 7, so there's my x. Here's my subtraction key. Don't get it confused with the negative key. There's my 7. Because I'm in classic mode, I'll have to close my parentheses. If you were in math print mode, get outside the absolute values by using your arrow keys, and then go plus 9. I again am going to start by going zoom and do z decimal. I'm going to go from negative 4.7 to 4.7 or negative 6.6 to 6. And the graph is off, all right? I mean, I'm supposed to be getting a point at 810. What I want to do is look at the point that negative 5.5 went to, which is 214. The reason I want to see this is that even though I don't see the graph because it's way up here, you can actually go second calc. You can go ahead and hit value. Because 2 does fall between negative 4.7 and 4.7, it will actually still give me a result. So at that point, I can get the value on even though I don't see it. But once again, if I do go second calc value and choose 8, all right, it does not work. And the reason for that again is 2 fell between negative 4.7 and 4.7 in the domain. And again, it's a little wider for the 84 CE, the color versions. But for this one, 214 fell in there, but 8 does not. If I would have gone and let's just say do zoom, and let's go and this time do Z standard, even if it is stretching it out a little bit, I know that 2 will fit in there. I know that 8 will fit in there because now it's going from negative 10 to 10. And so I can go second calc, and I can go value, and I can type in 2, get my result. I can type in 8 at 810, and I know I've done this one right. My third and final example will be translation example number 7, and I would like to enter the equation, and for this I need to put in a cube root. For doing a cube root, you don't see an actual key here. It's another math feature. So if I want to go to math, I can do cube roots by doing number 4. I will do that, but first I would like to explain what this one is. They call this the x root. In class I might call this the nth root, even though it doesn't show the n. For this to work, I actually need to type in what root I want. So if I want to do, let's say, a 5th root, I want to go 5, then I would go math, and then I would go the x root. And so this would be, let's say, the 5th root of x. Let me just show you what that would be in math print mode, because I think it's a little easier to visualize. If you can, remember, you can go down this way or you can go up. So if I hit math print and I go back to y equals, you'll see that it'll put the 5 into the index position, and it'll be the 5th root. So it's a little easier, actually it's a lot easier to kind of catch on what's going on. You have to be careful because do not get this confused with 5 times the square root of x. Math print mode, it's easy to see the differences, but if I go back to classic mode, move over here and hit the y equals, it really is the difference between seeing the x root key and the square root key. Well, it's all about a cube root. And so I could have put the 3 and then gone the math and then shows a number 5, but it's just easier for me to take advantage of the cube root, which is number 4, to type in my equation. And so I'll type in x plus 2. I'll close my radicand, and then I'll go minus 1. For this one, it's going to work very well. I'm going to go ahead and hit zoom. I'm going to hit z decimal. The key points that I'm looking for to verify that work is, remember, it may have been 1, 1 on the original graph, but I'm looking at the yellow graph here. And so when I go second calc and I do value, I can type in minus 1. This will give me the 0, so that's confirmed. I can type in the minus 2. That's the negative 1. That's confirmed. And meant to type in one more number. And for value, I can type in negative 3, and that's confirmed.